Welcome back, learners. So now we're moving on to our last concept, which is now the drawing of simple electric or simple series electric circuit. So we need to talk about the flow of charge, that why does the current stay the same at all points? We did say that in series, the current is going to be the same at whichever point that we're measuring. So why does that happen? The electrons in a conductor normally drift in various directions within a metal as shown here. So within a metal, the electrons will just be flowing haphazardly in every direction. Remember that all matter is made up of atoms, and atoms are made up of protons, electrons, and neutrons. The protons and neutrons are found in the nucleus of the atom, whereas the electrons are forming an electron cloud. They are the ones that are going to be moving around from one material to the other material. And in metals, we are talking about the delocalized electrons. Those are the ones that are flowing in an electric wire or in a conducting wire. So without any charge or without any energy given to those electrons, they will just be moving in various directions within a metal or inside the metal, as shown here. However, when we build a closed circuit, when we start now adding energy or supplying energy into the metal, so that's now building a closed circuit with a cell as an energy source, the electrons will now all begin to move towards the positive side of the cell. So now that means the electrons will start moving in one direction, in a certain direction, and that direction is towards the positive side of the cell or towards the positive terminal. So the rate at which these electrons move, it is determined by the resistance of the conductor. So that means if a conductor has a high resistance, or if the circuit has a higher resistance, that means the flow or the rate at which these electrons are going to be moving will be slow. Why? Because these are carrying a charge. The electrons are carrying a charge. So the electric charge is going to, or the electric current rather, is going to decrease once the resistance of the circuit or the resistance of this conductor increases. Right? So the relationship between the resistance and current still remains that when the resistance of the circuit, or in this case, when the resistance of a conductor increases, then the current is going to decrease. So again, the reason why the current stays the same at all points is that there are electrons everywhere in the conducting wires and electrical components. So that doesn't mean that when we start now adding a cell or adding an energy source or a battery into the circuit, the electrons will start moving from the battery. The electrons are always there in all the conducting wires and all the electrical components. The electrons are always there. So once we start now supplying those or that circuit with an energy source, the electrons will then start to move in one direction. However, the electrons or the electrical charge is still going to remain the same at every point because it is there. So now, when the circuit is closed, all the electrons start moving in the same general direction at the same time. Remember, when we are closing the circuit, that's now us now connecting the wires in the circuit. And when we are opening the circuit, that's now us disconnecting the wires in a circuit. Once we disconnect the wires, there won't be any current flow. There won't be any movement of electrons in the same direction. They will just be moving around in that particular wire as seen on the first picture here. They will just be moving around. But once we start connecting the cell or the battery, they will now move around in a certain direction towards the positive terminal. So now, this is why a light bulb turns on immediately when you close the switch. Because there are electrons already in the wire, when you close the switch, the light bulb immediately turns on because there are already the electrons there. It doesn't mean that when you switch on the light, the electrons will start running from the socket all the way to the bulb. They are already there. They're just now starting to move in one direction as you are turning on or as you are closing the circuit. When we move on and still talking about a series circuit, in a series circuit, all the electrons travel through every component and wire as they travel through the circuit. So every component that we find in an electric circuit will receive the electric charge or will receive the electrons, and those electrons will be traveling through all the components that we find in any electrical circuit. So that means all the electrons are going to experience the same resistance in series, because the resistance in series, the resistors are going to be connected one after the other. So remember, the bulbs are going to be connected one after the other as the electrons are moving through those bulbs. Remember, we're going to be using our bulbs as our resistors. So that means they are going to be moving at the same rate. So the electrons, because are experiencing the same resistance, they are going to be moving at the same rate. This means that when we're looking at this diagram here, the reading on all three ammeters is going to be the same. So for you to see if whether the resistance has increased or the current has decreased, we're going to be looking at the resistors as our bulbs. So we need to know that when we are adding more resistors in a circuit, the resistance is going to increase. Now the effect of that is going to be seen on the brightness of the bulbs that we are adding. So the more bulbs we add in an electric circuit, so that means the more resistors we are adding. Remember, bulbs are our resistors. The more bulbs we add in an electric circuit, we are increasing the resistance. So once the resistance increases, the current is going to decrease, which then means the resistors are going to receive less current because the current has decreased. So for you to be able to see that there's less current, the brightness is going to decrease. So the more resistors or the more light bulbs you add, the brightness of those bulbs that you're adding in that electric circuit is going to decrease. But the more or the less light bulbs you add onto the circuit, so the brightness of if we now drawing a circuit, if we draw a circuit with just one light bulb, this one light, let's just use the same battery so that we can keep things the same. So when looking at this circuit with two light bulbs and looking at this circuit with one light bulb, this circuit has more resistance as compared to this one. So that means the light bulbs of this circuit are going to be much dimmer as compared to this one. So this resistance of this circuit is going to be much lower than the resistance of this circuit. So that means the brightness here is going to be higher than the brightness on this circuit here. So the more light bulbs you add, the lesser the brightness. But then the less light bulbs we have in an electric circuit, the more the brightness. So basically, for you to be able to see that the resistance has increased or the resistance has decreased in an electric circuit, you need to look at the brightness of the bulb or the brightness of the resistor. The more brighter it is, that means there's more current there, meaning that the resistance is very low. Remember, high current or more current, less resistance. And more resistance, less current. So that means you can only see that when you are looking at the brightness of the bulbs. So in this case, whenever we are measuring our current at any point on this circuit, the brightness is going to be the same. So if we take our light bulb, remove it from where it is, and we connect it there, the brightness of this light bulb is going to be the same when it's here and also when it was initially. So that means if we are removed, so that means now the current that we are measuring at any point on this particular electric circuit is going to be the same, which is going to be shown by the brightness of the bulb. On this one, we have said that the light bulb is going to be brighter than this electric circuit that has two light bulbs, because there's more resistance on this particular electric circuit there. However, still on this electric circuit, wherever we put our light bulb, it is still going to be brighter than the one that has two resistors, because we have said the current in series remains the same throughout. So what we need to remember about these two electrical circuits is that they are both closed. That is why we can be able to have a current flowing from one terminal to the other terminal, and with that we can be able to also measure the brightness of these light bulbs that we have, either when we have one bulb or two bulbs. However, if one of them or if both of them were open, there wouldn't be any current flow, and because of that, we wouldn't be able to measure the brightness of the bulbs. Remember, once the circuit is open, the wires are going to be disconnected, or the circuit as a whole is disconnected, and because of that, there is no current flow. So if there's no current flow, we can't measure the brightness. So the important thing to remember here is that When we are adding the resistors in any electrical circuit or in any series electrical circuit, the brightness of the bulb is going to be decreasing because the resistance is increasing. The adding more bulbs, increasing the resistance, and therefore the brightness is going to be decreasing because the current is decreasing. However, the current is the same at each and every point that we are measuring in the series circuit. So with that said, I hope you learned something today, and I will see you next time. Bye.